So let's have our first practice video about second order differential equations. And this video, it comprises the topics from second order homogeneous differential equation up to the second order non-homogeneous differential equation 2.2, a given polynomial function. So let's begin. So here we have d squared t all over dn squared minus 2 dt all over dn minus 3t. So the first thing that you need to look at are the first thing that you need to look at is the letters given. All right. So we have t and we have n here. And obviously, if you have a letter on the numerator, this simply describes as your dependent variable. And here your n, since it is in denominator, this is your independent variable. Okay. So that means if by instance, let's just say our general solution for this problem is y is equal to ae raised to small ax plus be raised to small bx. So if this is our general solution and this is the format of it, what would be the changes? So the changes are your y would become t and your x will become your n. So we will have ae raised to small an plus be raised to small b. So that is your general solution. Okay. So let's go to the next thing you're going to look at, which is this one. Okay, on your right side. So on your right side, if it's 0, then this is a homogeneous. Okay, homogeneous DE. So now that we have observed two things before we're going to solve, now how can we find the general solution? Okay, so first things first, you need to convert this whole equation into the operator form. Oh, yeah, the operator form. There you go. So by doing so, we will substitute your d all over dn as your capital D. So we will have d squared of t minus uh, 2 dt minus 3t is equal to 0. And after that, you're going to factor out your t in this expression. So we will have quantity d squared minus 2 dt minus 3 times t. So this is your d operator form. Okay. Then after that, you're going to find your auxiliary equation. Okay. And by finding your auxiliary equation, what we're going to do is we will substitute your d as your m. All right. And equate this expression into 0. So we will have m squared minus 2m minus 3 is equal to 0. And after that, the next thing you need to do now is to find your m values. Okay. So since this is a quadratic equation, obviously there are two ways for you to solve the values in a given quadratic equation. You can either use any methods of factoring or quadratic formula. Okay. So for the sake of the viewers, okay, and since we just started in the first problem, I'm going to use two methods, which is number one, the factoring, and the other is quadratic formula. So that if we're going to proceed to the next problem, you already know what to do. Okay, so let's go. First, I will use factoring method. So in here, first, let's copy the quadratic equation. Oh, sorry. We have 2m minus 3. Okay. So by finding your m values here, okay, basically, think of a factors that would result to the product of -3. And if you're going to add them together, the result would be -2. Okay? This only works if your coefficient of m squared is 1. Okay? So since your coefficient of m squared is 1, so I can use this method. Okay? So by doing so is to think what are the factors that if you're going to multiply them, it will result to -3. And if you're going to add those factors, the result would be -2. So the factors are -3 and 1. Because -3 times 1 is -3. And -3 plus 1 is -2. Therefore, we will have 1 pp m minus 3 times quantity m plus 1. So this is the factored form for your quadratic expression of m squared minus 2m minus 3. Okay, that's it. Now, let's find our m values. Okay, so let's start first with your m minus 3. So transpose -3 to the right, we will have m is equal to 3. And then for your m plus 1, transpose 1 to the right, we have m is equal to -1. So you see we have two different m values. So if we have two different m values, therefore we're going to use our general solution. Hold on, let me finish writing. So we're going to use our general solution as y is equal to ae raised to small ax plus be raised to small bx. Okay? So first things first, you need to take a look at the letters given in your equation or your problem. So we have your t as your dependent variable and we have your n as your independent variable. So that means you're going to change your y into t and you're going to change your x into letter n. So we have ae raised to small an plus be raised to small b. So that is your general solution. Okay. Now, let's find our small a and small b. Basically, your lowercase letters. So to find your small a and your small b, just basically pick which one of your m value, which one of your m values would be small a or your small b. Just pick which one of them. So for me, I'm going to pick this one as my small a, and this one will be my small b. Therefore, I will have t is equal to ae raised to 3n plus be raised to -1 times n, negative n. So this is now my general solution. So that's it. But we're not done yet because as I mentioned, okay, we're going to find a particular solution. Okay. So in the title in the video itself, not only we're going to find the general solution, but we're going to find particular solution. Okay? But before that, as promised, okay, for the sake of viewers, to find your m values, I'm going to both use the factoring method and quadratic formula. So let's go to the quadratic formula. So in here, actually, if you're going to use quadratic formula, I think it's much more convenient. I mean, it is longer than doing factoring, okay? But to those who are having a hard time factoring, maybe this would be an advantage for you. So remember that the formula is -b plus or minus the square root of b squared minus 4ac all over 2a. So that's it. And remember that this is your a, this is your b, and this is your c. Okay? So, since we have this quadratic formula, okay, the first thing that you need to look at is the values of your b squared and your 4ac. Okay? Because in this technique, you will easily determine what will be your general solution. So let's start from here. What is your b squared? So since your b is your -2 and you're going to square it, so you will have 4. And next, your 4ac, so 4 times your a is obviously 1 times your c, it is -3. Okay? So 4 times 1 times -3, we have -12. And as you can see, the value of b squared is greater than the value of your 4ac. So if the value of your b squared is greater than your 4ac, therefore you're going to use this one as your general solution, which is y is equal to ae raised to small ax plus be raised to small bx. Okay? If and only if the value of your b squared is greater than your 4ac. Okay? Plus, this means that you will have two different m values. Okay? They are both real numbers, but they are different to each other. Okay? So, what if they are equal? Okay? What if they're equal? Okay? So, if you are saying that the value of your b squared is just the same as the value of your 4ac, therefore, you're going to use this as your general solution, which is quantity ax plus b times e raised to small ax. So this is the general solution that you're going to use if and only if the value of your b squared is equal to the value of your 4ac. This means that you have the same m values. You have two the same m values. Okay? So meaning whatever you will find there, okay, it represents basically what do you call this one? Two the same m values. All right. Let me give you an example. Um, for example, you have x minus 3 times x minus 3. If you're going to find the x values in these binomials, obviously in here this is 3 and in here this is 3. So meaning you have two the same m values. So you're going to use this one. Okay? So if you're going to use quadratic formula, okay, and you want to know what would be a general solution, then just basically use this technique. Okay? Because after you use this technique, okay, and you found out that these two terms, b squared and 4ac, are equal to each other, then you will use this one. Because basically, it means you have two the same m values. Okay? Sorry if I made it into sorry if I made it complicated. Basically, this case tells you that you have two the same m values. All right? And you will know it if your b squared is equal to 4ac. All right? So, what if we have a value of 4ac that is greater than your b squared? Or basically, your b squared is less than your 4ac. Then, your general solution would be y is equal to quantity cosine of bx plus sine of, sorry, plus b sine of small bx times e raised to small ax, wherein your m is equal to small a plus or minus small b times your I. Okay? So, basically, if you have a constant term in here, that would be the exponent of your e. And if you have a constant of b, which is here, located here, and it is partnered with your imaginary number, so you're going to put it as your input in your trigonometric function. So this means that you're going to have two complex values. Okay. So in other words, what do you call this one? You will have an imaginary result. Okay. So, okay, let's now go back to the point. Okay. So let's just say you use quadratic formula here, okay, to this quadratic equation. So you have your negative b. So since you have b as your negative 2, so you will have positive 2 plus or minus your b squared is 4 minus your 4ac is negative 12. So this would be positive 12, okay, all over 2 because 2 times a, which is 2 times 1, is equal to 2. Now, if you're going to simplify further, this would be 2 plus or minus square root of 6 all over 2, which is 2 plus or minus 4 all over 2, because the square root of 16 is 4. And since these two terms, 2 and 4, are both divisible by 2, we can divide them by 2. So we will have 1 plus or minus 2. Okay? So we can now get your m values. So first, m is equal to m plus 2, so you will have 3. And we have the other one. Wait, hold on. My application is lagging. There we go. So we have the other one, m minus 2. So you will have negative 1. So that means you have two different m values. Okay, so you're going to use this as your general solution. Okay, so yeah, that's what's your that will be the steps if you're going to use quadratic formula. Okay, okay. So yeah, yeah, that's it. That's how you use quadratic formula. Okay, when it comes to these cases. So let me erase this one because not only we're going to find the general solution, but we're going to find the particular solution. So let's proceed to finding your particular solution. So we have a given of x, sorry, this is not supposed to be x. Rather, this is supposed to be n. We have your n is equal to your 4, your t is equal to 1, and your dt all over dn is equal to 0. So let's find our particular solution. So obviously, we're going to substitute everything in your general solution. So we will put it here. There you go. So now let's find your, what do you call this one? Your particular solution. So since your t is 1, so we will have t, 1 is equal to ae raised to, your n is 4, so we have 3 times 4, which is your 12, plus be raised to negative n, which is negative 4. So in this working equation, pick one would you like to find first. Would you like to find your A or would you like to find your B? So for me, I'm going to start by finding my B. So by doing so, I'll transpose AE raised to AE raised to 12 on the left side. So we will have 1 minus AE raised to 12 is equal to BE raised to negative 4. Then divide both sides by E raised to negative 4. We will have 1 minus AE raised to 12 all over e raised to negative 4 is equal to b. Okay? We can still simplify this one. So we are going to decompose them into two fractions. So we will have 1 all over e raised to negative 4 minus ae raised to 12 all over e raised to negative 4 is equal to b. That's it. We can simplify this one further. This one will become e raised to 4. So if you don't know how I got this one, I suggest you should go back to your lessons in algebra. Basically, if you have a base and it has a negative exponent and it is located on the denominator, then you can bring it up, but the sign of the exponent will be changed. So if we have negative sign on your denominator, then if you're going to bring it up, that would be positive instead. Okay. Then for this one, on the second term, we will have AE raised to 12 minus 1pt negative 4. Okay. So if you still don't get how I come up with this one, then I suggest you should also go back to your algebra lesson because this is one of the laws of exponent. So if you have uh, two the same base and they have their own exponent. One is on the numerator and one is on the denominator. So just simply copy the base, which is your e, then subtract their exponents. So e raised to the exponent of the numerator minus the exponent of your denominator. So we have this one. Okay. So as a result, we will have e raised to 4 minus ae raised to 16 because 12 minus negative 4 will give you positive 16. Then you can factor out here. So you can factor out this expression by e raised to 4 because both of these terms are divisible by e raised to 4. So you will have e raised to 4 times quantity 1 minus e raised to 8. So that will be your b. However, how can you find your b if you cannot find your a? We cannot just simply substitute your b in your general solution. Okay, so we cannot do that. But um, as you can see, we have a given of dt all over dn is equal to 0. So it means we can have another equation if we're going to get the derivative of our general solution. Once again, since we have a given variable of dt all over dn, so that means we can have another equation by simply getting the derivative of your what do you call this one? Your general solution. So by doing so, I'm going to move wait, sorry. I'm going to move a little bit to the right. Here, there we go. All right. So by doing so, we will have the derivative of your t is equal to 3a times e raised to 3n minus be raised to negative n. That's it. Okay. So I got this one by simply getting the derivative of each of the given terms in your general solution. So let's substitute now. Since your dt is equal to dt all over dn is equal to 0, so we will have 0. Okay, so we have 3a times e raised to 3 times n, or basically 3 times 4. So we will have 12 minus b times e raised to negative 4. Okay, so in here, we can now substitute your b. Okay, so we will have 0 is equal to 3a times e raised to 12 minus 1pt, minus e raised to 4 times quantity 1 minus a raised to, times a, wait, 1 minus ae raised to 8 is equal to, is equal times e raised to negative 4. Okay, so we can simplify further by canceling e raised to 4 and e raised to negative 4. Okay? Basically, you have two the same bases, right? So if you have two the same bases and they have their own exponents, we will have, what do you call this one? Let me copy this one. We will have minus e raised to 4 minus 4. Okay? You're going to add their exponents. So 4 minus 4 is obviously 0. And anything raised to 0 is equal to 1, right? So therefore, since we have e raised to 0, so we will have 1. Okay? So 1 times quantity, 1 minus a e raised to 8. And if you're going to multiply 1 by this expression, the answer is still 1 minus ae raised to 8. No changes at all. Okay? So now let's distribute our negative sign to this expression. So we will have minus 1 plus ae raised to 8. Okay? So now let's find your a. So first, I'll transpose the negative 1 to the left. So I will have 1 is equal to 3ae raised to 12 plus ae raised to 8. Okay? So I will factor out my a and e raised to 8 because both of these terms are divisible by e raised to 8. So we will have 1 is equal to ae raised to 8 times quantity 3e raised to 4 plus 1. Okay, so that's it. And we will basically divide both sides by AE times quantity e raised to 4 plus 1, wait, plus 1 on both sides. Okay, so we will have 1 all over e raised to 8 times quantity 3 raised to 4 plus 1 is equal to your 8. So that's it. That's basically how you find your 8. You can still simplify this one if you like to. If you want to bring up your e raised to 8 on the top, there's no problem. And if you would like to, then you will have e raised to negative 8 all over 3e raised to 4 plus 1 is equal to your 8. So that's it. Okay, if that's what you want. Okay, if you want to bring up your e raised to 8 on the numerator. Now, since we found your a, now let's find your b. So in here, we will have e raised to 4 times quantity 1 minus times your a is 1 all over e raised to 8 times quantity 3e raised to 4 plus 1. All right, times e raised to 8 is equal to b. Since you have, what do you call this one? E raised to 8 on the denominator and on the right side of the fraction, we can cancel this out. So we will have e raised to 4 times quantity 1 minus 1 all over 3e raised to 4 plus 1. All right? We can also simplify this one by making this into a whole fraction. Okay? So basically, you can stop right now. But if you want to make these terms inside of the parenthesis into a whole fraction, then there's no problem. Okay? So if you're going to make this into a whole fraction, this would be e raised to 4 times quantity 3e raised to 4 plus 1 minus 1 all over 3e raised to 4 plus 1 is equal to b. So if you're asking me, how did I got or how did I come up with this one from this? So I apply butterfly technique. So we have 1 minus 1 all over 3e raised to 4 plus 1. So since your 1 here, it is a whole term, we can have a denominator of 1. Okay? So by applying butterfly technique, 1 times 3a raised to 4 plus 1. So we will have 3e raised to 4 plus 1. Then next, minus 1 times 1, we will have 1. All over 1 times 3e raised to 4 plus 1, we will have 3e raised to 4 plus 1. Okay? That's basically how you use butterfly technique. Okay. So yeah, going further, so we have 1 minus 1. If you're going to simplify it, we will have 3e raised to 4 only. Because 1 minus 1 is 0. So 3e raised to 4 plus 0 will give you 0. I mean, yeah, sorry, will give you 3e raised to 4. So yeah, basically that's it. That's how you get your b. Or you can factor out e raised to 4 here. There's no problem. You can bring out e raised to 4 here. So we will have e raised to 4 times e raised to 4 times quantity 3 all over 3a raised to 4 plus 1. Okay? So, as a result, if you're going to simplify it, we will have e raised to 8 times quantity 3 all over 3e raised to 4 plus 1. That is your b. So therefore, now that you have found your a and your b, we can now substitute it in your general solution. So remember that your general solution, let me put it here. There you go. Is this one. So we will have now your particular solution as t is equal to your a, which is 1 all over e raised to 8 times quantity 3e raised to 4 plus 1. all right, times e raised to 3n plus your b, e raised to 8 times 1 pt. Uh, you know what? I'm just gonna, you know what? Bring this one on the numerator. I think that would be far better. So we will have 3e raised to 8 all over 3e raised to 4 plus 1 times e raised to negative n. So that's it. We can still, what do you call this one? We can still simplify this one if you would like to, right? We have on your first term e raised to 8, and we have on the right e raised to 3n. We can simplify this one. So we will have t is equal to e raised to 3n minus 8 all over 3e raised to 4 plus 1. We can do that. Okay. So how did I come up with this one? Basically, I uh, group with e raised to 3n and e raised to 8. So I have e raised to 3n all over e raised to 8. So I can have e raised to 3n minus 8. I can do that. Okay, I can do that. Then after that, I'll put this one on the numerator. So I will have this one as a result. So yeah, that's it. Okay. And for this one, we have 3e raised to 8 times e raised to negative n. So I will have 3e raised to 8 minus n all over 3e raised to 4 plus 1. Okay, so how did I come up with this one? Simple, if you're going to multiply e together, e raised to 8 times e raised to negative n, we will have e raised to 8 minus n. Okay, or basically 8 plus negative n. So we will have 8 minus n. Okay, so if you have two the same bases, okay, and you're going to multiply them together and they have their own exponents, you're going to add them together. So if you're going to add 8 and negative n, you have 8 minus n. Right? And since we have this one, we can combine them further. Okay? Since they have a similar denominator, since they have the same denominators, so both of them are similar fractions. So we will have e raised to 3n minus 8 plus 3e raised to 8 minus n all over 3e raised to 4 plus 1. Okay? So this is now your particular solution. All right? Once again, this is now your particular solution. Wait, let me fix that. Okay. So that's it. All right. That's how you basically do it. Yeah. So, sorry. So we have the second problem, which is 4d squared z all over dt plus 5dz plus t is equal to n. 2. So as you can see, what do you call this one? Where was I? First is that the letters are different. So we have your z as your dependent variable, and we have your t as your independent variable. That's it. All right. And as you would observe on your right side, this is not 0. So this is non-homogeneous. Okay. Once again, this is non-homogeneous. Okay. So if this is non-homogeneous, so what you're going to do? Your general solution would be y is equal to u plus v. But since your dependent variable is your z, therefore we will have the general solution of z is equal to u plus v. So that means you're going to find your u and your v. Okay, your u function and your v function. So let's start first by finding your u function. So by finding your u function is the same way on how we find a general solution in our first problem. Basically, the way how you find the general solution for a second order homogeneous differential equation is the same as how you find your u function. It's the same. So that will be our that will be our guide for us to find your u function. So with that being said, let's start by substituting d all over dt as our capital D. We will have now 4d squared of z plus 5dz plus, wait a minute, this is wrong. Wait, forgive me. This is supposed to be z, not z. Okay, let me change that. This is supposed to be z. All right, forgive me. So let's go back. Yeah, plus z is equal to 2. Now, just like what we did in the previous problem, we will factor out z in this expression. So we will have 1dt 4d squared plus 5d plus 1 times z is equal to 2. Okay? Remember, this is your d operator form. Okay? So next, we're going to substitute your d as your m to find your auxiliary equation. Okay, so not only we're going to substitute your d as your m, but also to equate this equation, this expression for d squared plus 5d plus 1 to 0. So we will have 4m squared plus 5m plus 1 is equal to 0. So this is your auxiliary equation. Now, what we're going to do is to find your m values. So for me, I could find this one by simply factoring. And when it comes to quadratic formula, once again, guys, it's up to you. Okay, if you're going to use quadratic formula or any methods of factoring, either of the two. Okay, so it's up to you now. Okay, so I think I've already what do you call this one? Discussed if you're going to use quadratic formula and what happens if your b squared is greater than your 4ac, equal to 4ac, or less than your 4ac, right? And you're going to use their general solution, right? I think I already discussed that. So yeah, okay. So for me, I'm going to use a method of factoring, which is slide and divide method. Okay. So in this method, first thing to do is that this coefficient of 4, I'm going to slide it to 1. So I will have m squared plus 5m plus 1 times 4. Okay, is equal to 0. Since I have 1 times 4, so I will have 4 as a result. And what I'm going to do is I'm going to find the factored form of this expression. So the factored form of this expression will be m plus 4 times quantity m plus 1. Okay, so how did I get this one? Simply, you have to think of the factors of 4. Okay, so make sure that these factors, okay, if you're going to multiply them, it will result to positive 4. And if you're going to add the factors together, the result would be 5. Okay, again, so how to find factors? I will basically make sure that I'm going to find factors that will give the result of positive 4 if you're going to multiply them together. Okay? And after you find these factors, that if you're going to multiply them, it will result to positive 4, then I have to make sure that if I'm going to add them together, the result is positive 5. So what are the factors of 4? Okay, so I can have, so what will be the factors of the product of 4? So I can have 4 and 1 because 4 times 1 is positive 4. And if I'm going to add 4 by 1, I will have 5, positive 5, which is the same as the coefficient of your m. Therefore, your factored form will be 4 and 1. So hence, we will have m plus 4 and m plus 1. So that's it. Now, okay, now that this is your factored form, and remember that I slide 4 to the 1, we're going to divide the numbers by 4. So 4 divided by 4, we will have positive 1, and 1 divided by 4 is 1/4. So it is not basically divisible by 4. So if that's the case, we're going to bring 4 to your m. So we will have 4m plus 1. That's it. Now let's find your m values. So we have m plus 1 is equal to 0. Transpose 1 to the right, we will have m is equal to negative 1. Then we have 4m plus 1 is equal to 0. So transpose 1 to the right, we will have 4m is equal to negative 1. And divide both sides by 4 to remove 4 on the left side. Hence, we will have m is equal to negative 1/4. So these are the values of your m. And since both of them are not the same to each other, like they are real numbers, but they are different to each other, therefore, you're going to use your general solution as y is equal to ae raised to small ax plus be raised to small bx. Okay? So remember, the letters should be changed. So what is your y? Your y is your z, and your x is your t. So we have ae raised to at, small at I mean, plus be raised to small bt. Okay? And let's find your small a and your small b. For me, this will be my small a, and this would be my small b. So I will have z is equal to ae raised to negative t plus be raised to negative 1/4 t. Okay? And since I told you earlier that the way how you find the general solution for your second order homogeneous, it's the same way on how would you find your u function. Therefore, this, okay, this one will be your u function. So your u is equal to ae raised to negative t plus be raised to negative 1/4 t. Okay? So that will be your u function. Now, let's find for your v function because we are not done yet. So let's go find your v function. So for your v function, okay, you need to be very aware of your functions to your right. Okay? So we have your 2. So we have a function of 2. So this is just a constant function. So what would be the what would be the effect if your function is a constant? Okay, so you have conditions. Okay, you have certain conditions to follow. If your function on the right is 2, okay, first condition, if your u doesn't contain a constant term. Okay, let me put constant term. There we go. Okay, so basically, if your u function do not have constant term, even at least one, therefore your v would be your k. All right. Second condition would be the contrary to the first condition. So if your first condition is about your u doesn't have a constant term, then on your second condition is the opposite. Okay? So once again, first condition, if your u doesn't have a constant term, then your v is equal to your k. Otherwise, your second condition would be v is equal to kx. Okay, you guys get what I mean? For your, what do you call this one? For your first condition, if your u does not contain constant term, then v is equal to k. But if your u does contain a constant term, then your v is equal to kx. Okay. Basically, yeah, I simplify it. Okay, sorry if I made it into, a complicated explanation. Okay, so let's observe your u. Your u is ae raised to negative 12 and be raised to negative 1/4 t. So, wait, what? Ae raised to negative t plus be raised to negative 4t. Okay, 1/4 t. There we go. So since there's no constant term here, okay, there's no constant term. So if there's no constant term, then we will use the first condition. Your v is equal to your k. Okay? We will not use this one because there is what? There is no constant term. And if there will be a constant term, we will use this one. But since we do not have at least one constant term, then we will use v as your k. So after that, what are we going to do? We will substitute it to your z in the d operator form. Okay? So let me copy this one. We will have this. Okay? So in here, we will have 1tt for d squared plus 5d plus 1 times your v is equal to 2. So remember that your v is equal to k. So we will have k. Okay? And by the way, remember that your k is a constant. Okay? It is a letter, but it is constant. Okay? Now we will distribute your k to this expression. So we will have 4d squared of k plus 5d of k plus k is equal to 2. Okay? And remember that your d is equal to d all over dt. So we will have 4 times d squared all over dt squared of k plus 5 times d all over dt of k plus k. So obviously, if you have this one, it means you're going to get the derivative of your k. So for your first term, you have the second derivative of your k, basically the second derivative of your constant. So this is 4 times 0. Next, 5 times. So you have the derivative of your k here. So the derivative of your k, which is a constant, so this will be also 0. Then copy the other terms. So 4 times 0 is 0. 5 plus 0, 5 times 0 is 0, plus k is equal to 2. So you have k as a result. If you're going to add 0, okay, and 0 and k on the left side, you will have k. And on the right side, you have your 2. So therefore, your k is equal to 2. And remember that your v is equal to your k, right? Remember this one, right? So therefore, your v is equal to 2. Okay? Therefore, your general solution will be, okay, z, let me write it here. The z is equal to, wait, it's better if I'm going to write it here. Z is equal to u plus b. So this is z is equal to your u, ae raised to negative t plus be raised to negative 1/4 t plus your v, which is your 2. So this is your general solution. Okay? That's how you find your general solution. Okay. Now, let's find now your particular solution. Okay, since we're not done yet. Okay. So let me put it here. There we go. So let me move. Okay. Let's now find your particular solution. So let's just say that your z is equal to 5, your t is equal to 1, and your dz all over dt is equal to 2. What would be now your particular solution? So let's substitute everything in the general solution. So we will have 5 is equal to ae raised to negative t or negative 1 times t. Or wait, sorry, I'm wrong. Substitute your t in here. So we will have negative 1. Yeah, negative 1. Wait, yeah. So we have 5 is equal to ae raised to negative 1 plus be raised to negative 1/4 times t. Okay? So your t is 1. So meaning your, what do you call this one? Your product will be negative 1/4. Okay? If you're going to multiply by 1. Then plus 2. So once again, substitute your z and any other variables here to your general solution. So your z will become 5 and your t will become 1. So we have AE raised to negative 1 and BE raised to negative 1/4 times 1, which is still negative 1/4. Okay? So now pick which one would you like to find. So for me, I will still find my B. So I'll transpose 2 on the left. I will have 5 minus 2 is equal to AE raised to negative 1 plus BE raised to negative 1/4. So I will have sorry, I will have 3. Okay, then I have AE raised to negative 1 plus BE raised to negative 1/4. So I'll transpose this one on the left. I will have 3 minus AE raised to negative 1 is equal to BE raised to negative 1/4. So to find your B, just divide both sides by E raised to negative 1/4. Okay, so I will have now 3 minus AE raised to negative 1 all over E raised to negative 1/4 is equal to your B. So you can use that, you can use this one as your B, or you can still simplify. Okay, we can decompose this full fraction into 2. We will have 3 all over E raised to negative 1/4 minus AE raised to negative 1 all over E raised to negative 1/4 is equal to your B. Okay, so in here, we can have 3E raised to 1/4. I already explained earlier that we can have a base on the denominator that has a negative exponent uh, on the, well, wait, sorry. Let me rephrase what I'm trying to say. Basically, I've already explained this type of scenario or case, okay? So basically, if you have a term on the denominator and you have a negative exponent, you can bring it up, but you're going to change its sign. So we have from negative e raised to 1/4, okay, on the denominator to e raised to 1/4 on the numerator. So we will have 3 times e raised to 1/4. And here, okay, so we have both e's on the numerator and on the denominator. Okay, so we will have ae raised to negative 1 minus negative 1/4. So this would be positive 1/4. Okay, so if that's the case, so negative 1 plus 1/4, we will have negative 3/4. Okay, we have negative 3/4. Okay, and that will be your B. Okay, this will be your B. You can actually factor this out if I'm correct. Okay, if I'm correct, you can factor this out. But if you don't want to, then you can just leave this at it is. This is now your B. Okay, this is now your B. All right. Or you know what? Yeah, I can actually factor this out if I could what do you call this one? If I could do that. Let me factor this out. I will have e raised to 1/4 times quantity 3 minus a times e. This one, if I'm going to factor out this one, okay, this will be this would be 1. All right, this would be uh, -1. There you go. Okay, because if you're going to add 1/4 and -1, the result would be -3/4. So yeah, I'm correct. So this will be now your B. Now again, you cannot find your B by simply substituting this one to your general solution. So we cannot do that. Okay? And especially that we are also finding your A. So by doing so, okay, we can have another equation to substitute. Because remember, we have dz all over dt. Okay, so that means we're going to get the derivative of your general solution. So we will have dc all over dt is equal to -a e raised to -t minus 1/4 of b times e raised to -1/4 t plus 0 because your 2 here is a constant term. So the derivative of a constant term is just 0. Let's substitute. So your dz all over dt is 2 and we have -ae raised to t, which is your 1. So we will have -1 minus 1/4 times be raised to -1/4 times your t, which is your 1. So it is still -1/4. Okay. Now, we can substitute your b in here. So we will have 2 is equal to -a e raised to -1 minus 1/4 times e raised to 1/4 times quantity 3 minus ae raised to -1 times e raised to -1/4. So as you can see, we have two e's and they have their own exponents. Okay, so if you're going to find the value, simplified form of e raised to 1/4 times e raised to -1/4 1. So they will be cancelled. Okay, but if you want me to take it slow, then there's no problem. So we have -1 minus 1/4 times quantity 3 minus ae raised to -1 times e raised to 1/4 minus 1/4. So if you're going to subtract these two, you will have 0. Okay? And anything raised to 0 is equal to 1. So therefore, we will have times 1. And if you're going to multiply this one by 1, the answer is still 1. The answer is still this one. Because anything that you're going to multiply by 1, the answer is still anything. So multiply -1/4 times 3 minus ae raised to -1 by 1, the answer is still -1/4 times quantity 3 minus ae raised to -1. Okay, still the same. All right, so now let's find now your a. For me, I'm going to make this one into a whole fraction so that it would be easy. So by applying butterfly technique, I will have -4ae raised to -1 minus quantity 3 minus ae raised to -1. And since we have a negative sign here, oh wait, sorry, all over 4. And since we have negative sign here, we can distribute the negative sign to these terms. So we will have -3 plus ae raised to -1 all over 4. So we can simplify further. We will have 2 is equal to negative, what do you call this one? We can simply simplify by combining these terms. So we will have -4e raised to -1 plus ae raised to -1. We will have negative, wait. No. Sorry. I'm wrong. I'm quite in a rush. Sorry. So we can simply combine similar terms. So we can have -4e raised to -1 plus ae raised to -1 minus 3. There you go, all over 4. Then what I can do is I can cross multiply. I can multiply 2 by 4. Okay? Basically cross multiplication. So I will have 2 times 4, 8 is equal to -4 times e raised to -1 plus ae raised to -1 minus 3. Okay. Then what I will do is I will transpose the first term and the last term on the left. So I will have 8 plus 3 minus 4e raised to negative 1 is equal to ae raised to negative 1. So I will have 8 plus 3 is obviously 11. 8, 9, 10, 11. Yeah, 11 minus 4e raised to negative 1 is equal to ae raised to negative 1. So divide both sides by e raised to negative 1, we will have 11 minus 4e raised to negative 1 all over e raised to negative 1. And we can still simplify this one. So I will decompose this fraction into two fractions. So 11 all over e raised to negative 1 minus 4e raised to negative 1 all over e raised to negative 1. Okay. So this one, I can make it into 11 times e raised to 1 or just simply 11e minus, I can cancel out the e raised to negative 1 on the numerator and on the denominator. So I will have minus 4. So that is now my a. All right, that is now my a. All right, now let's find your b. We're going to substitute your a going back to that equation. So we have e raised to 1/4 times quantity 3 minus quantity 11e minus 4 times e raised to negative 1. Okay? So the result would be e raised to 1/4 times quantity 3 minus 11. If you're going to distribute negative. If you're going to distribute e raised to negative 1 to this term, we will have 11 as a result. Because if you're going to multiply 11e times e raised to negative 1, we will have 11 times e raised to 1 minus 1, which is 11 times e raised to 0. And anything raised to 0 is equal to 1. So we have 11 times 1, which is, as a result, it's still 11. So we have 3 minus 11. Okay? Then, distribute negative sign and e raised to negative 1 to your negative 4. So we will have positive 4e raised to negative 1. So now let's simplify. 3 minus 11. Okay, we will have 11, 10, 9, 8. So we will have negative 8 plus 4e raised to negative 1. Okay? And these two terms, negative 8 and positive 4e raised to negative 1, are both divisible by 4. We can factor out 4 here. So we will have e raised to 1/4 times 4 times quantity negative 2 plus e raised to negative 1 is equal to your b. So you will have 4 times e raised to 1/4 times quantity e raised to negative 1 minus 2 is equal to your b. I just basically rearrange the position of negative 2 and e raised to negative 1. So that will be now your b. So since we found your a and your b, we can now find your particular solution. So let's copy first, let me paste first the general solution. So we will now substitute. So we will have z is equal to, your a is 11e. Hold on, wait. We have 11e minus 4, okay, times e raised to negative t plus your b, which is your 4e raised to 1/4 times e raised to negative 1 minus 2, okay, times e raised to negative 1/4 t plus 2. So we can still simplify this one because take a look at the second term. Okay, we have 4e raised to 1/4 and we have e raised to negative 1/4. So if you're going to multiply these two, the result will be cancelled out. Okay, is the same thing what we did in which part again? I kind of forgot. No. Which, wait. The same thing what we did in here, if I'm correct. Wait, am I right? Where was it? Yeah. The same thing here what we did here. All right, what we did here. If we multiply e raised to 1/4 and e raised to negative 1/4, the answer is 1. Okay, so we can just simply cancel them both. Okay. So if you still don't get what I mean, then I can still explain if you like to. So let me copy this one. 11e minus 4, wait, minus 4 times e raised to negative t, negative t plus 4 times e raised to, no, nah, never mind. I'm actually wrong, guys. I'm actually wrong. What I call this one? You cannot cancel this out. Forgive me. You cannot cancel this out. Do you know why? Because 1/4 and negative 1/4 are not the same. Because negative 1/4 has t, and this one has no t. So yeah, I'm actually wrong. Forgive me. But we can still simplify this one because if you're going to multiply this one, right, you're going to add the exponents together. So we can have z is equal to quantity 11e minus 4 times e raised to negative t. Okay, plus 4e raised to 1/4 minus 1/4 t. Okay, or you can factor this out because these two terms are divisible by 1/4, so we can have 4e raised to 1/4 times quantity 1 minus t. There you go. Then times e raised to negative 1 minus 2 plus 2. So that will be your particular solution. Again, if you still don't get how I come up with this one, right? I cannot cancel this out, right? This e raised to 1/4 and e raised to negative 1/4, right? I cannot cancel that out, okay? However, I can still combine them together. Because if you're going to combine e raised to 1/4 and e raised to negative 1/4, okay, I will have, wait, this is 1/4. I will have e raised to 1/4 plus negative 1/4 t, or 1/4 minus 1/4 t. So I can factor out 1/4 in that particular expression on the exponent of your e. So we will have e raised to 1/4 times quantity 1 minus t. That's it. Okay. So that's how I got it here. Okay. So yeah, that is your particular solution. Okay. So yeah, particular solution. Okay. So yeah, that's it. Now let's go to the last problem of this video. So we have 5d squared r all over dx squared plus 510dr all over dx plus 10r is equal to 20x minus 25. So first thing again to observe is the letters. So we have your r, okay, on the top, and we have your x on the bottom. So obviously this is your dependent variable, and here obviously this is your independent variable. Okay, so that's the first thing that you need to observe first. And the second thing is on the function on the right. Since we have 20x minus 25 and it's not obviously 0, so this is what you call as your non-homogeneous. Basically, if on the right side it is not 0, then it is non-homogeneous. Okay, now let's now get our general solution. But before that, we can simplify this equation. Remember, take a look. We have 5, 10, 10, 20, negative 25. You see, um, I'm sorry, all of the terms here, 5, 10, 10, 20x, and negative 25, are all divisible by 5. So we can divide both sides by 5. So we will have the simplified problem of d squared all over dx squared plus 2dr all over dx plus 2r is equal to, 4x minus 5. So this is your simplified um, equation to your given problem. So we're going to base everything in here. Okay? So once again, since it is a non-homogeneous DE, your general solution would be y is equal to u plus v. Okay, it's u plus v. So now let's substitute. Okay, remember that again, your dependent variable is your r. Therefore, you will have r is equal to u plus v. Okay, now let's find your u function. Okay, so as always, the way how you find your u function is the same way how you find the general solution of a second order homogeneous differential equation. So we will substitute capital D, okay, for your d all over dx. So we will have d squared r plus 2dr plus 2r. Am I right? Yeah, 2r is equal to 4x minus 5. So we're going to factor out your r here. So we will have d squared plus 2d plus 2 times r is equal to 4x minus 5. Okay, that's it. So this is your d operator form as always. Now we will substitute your d as your m and equate this expression to 0. Okay, to find your auxiliary equation. So this is m squared plus 2m plus 2 is equal to 0. So this is your auxiliary equation. And now let's find your m values. Excuse me. So for me, I think this is obviously not factorable. So I'm going to use quadratic formula. So let's recall, this is your A, this is your B, and this is your C. So let's have this one. Negative B plus or minus the square root of B squared minus 4AC all over 2A. So since I'm using quadratic formula, now I have to use this technique, B squared and 4AC technique. So what is the value of my B squared? Since I have 2 as my B, so I'm going to square it, I will have 4. And here I will have 4 times your A is 1 and your 2 is C. Okay. So I have 4 times 1 times 2. So 4 times 1 times 2, I will have 8. So as you can see, my value of B squared is less than the value of 4AC. Therefore, I will use the general solution of 8 times cosine of small bx, sorry, quantity 8 times cosine of small bx times b times sine of small bx times e raised to small ax, where your m is equal to a plus or minus b times I, or your imaginary number. And remember, in terms of lettering, your dependent variable is your r, and your independent variable is your x. So we will have r is equal to a times cosine of small bx plus b times sine of small bx times e raised to small ax. And that will be your u function. Okay, remember, the way how you find the general solution of your second order homogeneous differential equation is the same way on how would you find your u function. Okay, so remember, your m is equal to a plus or minus bi. Now let's go. So this will be negative 2, that's your b, plus or minus b squared, which is your 4, minus 4ac, 8. Okay, all over 2 times a, which is 2 times 1, basically. So 2 times 1 is your 2. So you have negative 2 plus or minus 4 minus 8 is negative 4. Okay, all over 2. And since we have the square root of negative 4, the result would be the square root of, the result is 2 times your I. So if you're asking me how did I get it, it's simple, right? I have negative 4, okay? I can decompose this one into 2 factors. So from negative 4 into 4 times negative 1, okay? So
I can separate -4 and -1 by their own square roots. So I will have so I will have square root of 4 times the square root of -1. And recall that your I is equal to the square root of -1. Therefore, I will have 4 times your I. And remember that the square root of 4 is equal to 2. Therefore, I will have 2 times your I all over 2. Okay? That's how you get it. So now, since this -2 and 2i are divisible by 2, so we can divide them by 2. So we will have -1 plus or minus your I. And that will be your m value. So what will be now your u function? So as mentioned, that your u function is this one. Okay? And again, how will you find your small a and your small b? So your small b is located at the what? At the coefficient of your I. So what is the coefficient of your I? The coefficient of your I here is your 1. So therefore, we will have a times cosine of 1 times x, or just simply as cosine x. So the same thing to your sine. So b times sine x times e raised to a. Your a is basically the constant term. So since your constant term here is -1, so we will have -1 times x. So -1 times x is just -x. That will be your u function. And we're not done yet because we need to find your v function. So to find your v function, let me just move here for a moment. Nah, I think that would be a huge mess if that would be. Sorry, forgive me. Basically, I'm actually complaining if I'm going to move to the right since I have solutions here. Okay, but instead I'm just gonna start here. Okay. Anyways, okay, forgive me. Let's now find your v. Okay, forgive my rant. Okay. So to find your v, be observant to your function on the right side. So your function on the right side is a polynomial function. So we have 4x minus 5. So if it is a polynomial function, then your v is equal to ax plus b. So what I did here, I just copied the format of your function. Okay? So from 4x to ax and from -5 to b. So I will have ax plus b. So again, how did I get ax plus b? Okay, so I just copy the format of your function. We have 4x minus 5, right? So since if I have 4x minus 5, therefore my v will be ax plus b. I just copied the format, but I changed the numbers into letters. So from 4 to a and from -5 to b. So after that, let's substitute your v to your d operator form to be specific to your r. So we will have d squared plus 2d plus 2 times your r. And remember, I said your v would be your r. Okay, so this would be times v is equal to 4x minus 5. And remember that your v is equal to ax plus 5. So we will have ax plus 5 plus b instead. So what we're going to do is we will distribute this binomial to the terms given to this expression. So we will have d squared of ax plus b plus 2 times d of ax plus b plus 2 times quantity ax plus b, okay, is equal to 4x minus 5. So again, your d is basically d all over dx. So we will have d squared all over dx squared, okay, of ax plus b. Okay, there you go. Plus 2 times d all over dx of ax plus b. Wait. Plus 2 times ax plus b is equal to 4x minus 5. So as always, if you would take a look at this one and this one, you're going to get the derivative. So for your first term, you're going to get the second derivative. So what is the second derivative of your ax plus b? And remember, since I changed the numbers into letters, which is 4 to a and negative 5 to b, this means that the letters here, your a and your b, are still your constants. Okay, so these are your constants. Your A and your B are still your constants. Okay, so what is the derivative or second derivative of ax plus b? The answer is 0. Okay, plus 2 times the derivative of ax plus b, it is basically a. Then distribute your 2 to this expression. We will have 2ax plus 2b is equal to 4x minus 5. So let's simplify further. We will have 2a plus 2ax plus 2b is equal to 4x minus 5. Now, how can we find your a and your b? Since it is required for us to find your a and b. So how will you find, once again, your a and your b? So in this case, since this one is already simplified, we're going to equate the terms on the left and on the right side that are similar. Again, we're going to equate the terms, okay, on the left side and on the right side that are similar. So first, let's start with 2ax. So since we have 2ax, the only term that has x on the left side, do you think on the right side there is a term that has x? Or basically, there is a term that is similar for your 2ax? The answer is yes, which is your 4x. Okay? Since 2ax and 4x are similar, therefore we will have 2ax is equal to 4x. There we go. Okay? Since 2ax and 4x are similar, so we will have 2ax equal to 4x. And since we have x on both sides, we can just simply cancel out. So we will have now 2a is equal to 4. And that will be our first equation. Now, how about your constants? We have your 2a and your 2b. These two are your constant terms. Do you think on the right side, there is a constant term as well? The answer is yes, negative 5. Since 2a, 2b, and negative 5 are constant terms, then we will equate them together. So on the left side, we have 2a plus 2b. And your there we go. So we have 2a plus 2b is equal to negative 5. So again, how did I come up with this one? So basically, we're going to equate terms that are similar to each other. So on the left side, right, we have 2ax. So on the right side, we have 4x. Since both of them are similar, so we will have 2ax is equal to 4x. And since there are x on both sides, so we will have 2a is equal to 4. So in here, on the left side, we have 2a and 2b. These two are your constant terms. The main reason why that they are constant terms is because your a and your b, despite that there are letters, they are still act as a constant. So constant times constant is still a constant term. So therefore, 2a and 2b are the constant terms on the left side. And on the right side, we have a constant term of negative 5. So therefore, let's equate two sides based on their similar terms. So on the left side, your constant term is 2a and 2b. And on the right side, your constant term is negative 5. So that is your second equation. Now, let's find your a and your b. So this one is actually easy. Okay? If you're going to find your a, base it here. Okay? So we have 2a is equal to your 4. So divide both sides by what do you call this one? Divide both sides by 2, we will have a is equal to 2. So it's easy. That's your A. Okay, your A is equal to 2. Now let's find your B. So since your 2A is equal to 4, so we can have 4 plus 2B is equal to negative 5. Okay? So once again, how did I get from 2A to 4? Since your 2A is equal to 4, so we can just substitute your 2A as 4. So transpose 4 to the left, we will have 2B is equal to negative 5 minus 4. So we will have 2B is equal to negative 9. So divide both sides by 2, we will have your B is equal to negative 9 all over 2. Okay, so that's it. Now that we have found your A and your B, we can now substitute it to your V. So remember that your V is equal to AX plus B. So since your A is equal to 2, so we will have 2x. And since your B is equal to negative 9 all over 2, so we will have 9 all over 2. And that is now your V function. Now let's get your general solution. So your general solution will be, hold on, will be, what's that? R, right? R is equal to U plus your V. So your R is 1pt A times cosine of x plus B times sine of x times E raised to negative x plus your V, which is your 2x minus 9 all over 2. That is now your general solution. Okay, there we go. Now let's find your particular solution. Okay, so for your particular solution, wait, let me move to the right now. There you go. I'm going to substitute here. So for your particular solution, first we have a given terms of x is equal to 0, r is equal to 0, and your dr all over dx is equal to 1 half. Okay, so let's substitute everything in the general solution. So your r is 0 is equal to 1pt a times cosine of 0 plus b times sine of 0 times e raised to negative 0, or just simply as 0, because negative times 0 is still 0, plus 2 times 0 minus 9 all over 2. Wait, I'm using different font color, so just to mind it anyways. So let's simplify. Cosine 0 is 1. So we will have a times 1 plus your sine 0 is actually 0. So you will have b times 0. And here we have e raised to 0. So basically this is 1 because anything raised to 0 is 1. And 2 times 0 is 0 minus 9 all over 2. So we will have 0 is equal to 1pt a plus 0 times 1. And if you're going to simplify them, you're going to have a times 1 because a plus 0 is a. And a times 1 is still your a. There you go. And 0 minus 9 all over 2 is still 9 all over 2. So this one is easy. You can now find your a. So transpose the constant on the left. So we will have 9 all over 2 is equal to your a. That's it. But we're not done yet because we need to find your b. And again, you cannot simply substitute your a in your general solution. Okay? And as you can see, we have dr all over dx. So we can have another equation that you can use to substitute your a. So by getting your dr all over dx, you're going to get the derivative of your general solution. So we will have dr all over dx is equal to, by getting the, what do you call this one? The derivative for this one, you will have negative, wait, negative times quantity a times cosine x plus b times sine x times e raised to negative x plus e raised to negative x times negative a times sine x plus b times cosine x. Then next, get the derivative of your 2x, we will have plus 2. And the derivative of your constant negative 9 all over 2, we will have plus 0. So 2 plus 0 is just 2. Now, let's substitute. Okay? Your dr all over dx is 1 half. And here, there we go. Negative times quantity. So your 0 is in your x. So we have a times cosine 0 plus b times sine 0 times e raised to negative 0. Or basically, it's still 0 because negative times 0 is still 0. Plus e raised to negative 0, or once again, it is still considered as 0. Times quantity, negative a times sine 0. Wait, there you go. Plus b times cosine of 0 plus 2. Okay? So let's now basically simplify. We have 1 half is equal to negative quantity. Cosine 0 is 1. So we have a times 1. And a times 1 is still 1. So we will have a plus b times sine 0. So your sine 0 is 0. And b times 0 is equal to 0. So we will have 0. Times e raised to 0 or 1. Okay. So yeah, plus e raised to 0 is 1 times quantity, negative a times sine 0. And remember that your sine 0 is 0. So negative a times 0 is 0. Plus b times your cosine 0 is 1. So b times 1 is b. And plus 2. So we can now simplify further. This would be 1 half is equal to negative a plus b plus 2. Okay? Because a plus 0 is a. So a times 1 is still 1. But since we have negative sign, so we will have negative a. Next here, on the second term, we have 1 plus 0 plus b. So 0 plus b is b. And b times 1 is b. And copy the rest of the term. Remember that your a, wait, sorry. Your a is equal to 9 all over 2. Therefore, you will have 1 half is equal to negative 9 all over 2 plus b plus 2. So let's find your b, since that's the only missing variable. That's the only missing letter. So transpose 9 all over 2 on the left side, we will have 1 half plus 9 all over 2. And transpose 2 on the left side as well. So we will have minus 2 is equal to your b. So 1 half plus 9 all over 2, we will have 10 all over 2 minus 2 is equal to your b. And 10 all over 2, in short, it means 10 divided by 2. So we will have 5 minus 2 is equal to b. So 5 minus 2 is 3. And that is your b. So we're actually done. It's actually easy. But anyways, since this is your general solution and we have found your a and your b, therefore your particular solution will be r is equal to your a is 9 all over 2. So we will have 9, oh wait, sorry. Quantity 9 all over 2 times cosine x plus b, which is your 3, times sine x times e raised to negative x plus 2x minus 9 all over 2. And that is now your particular solution. Ah, wait. It triggers me. Wait. Let me write T. There you go. That's it. So I hope you have Marcos one. I hope you have learned something in this video. Sorry if I am too rushy. Like I'm too quick to explain, especially if I explain something in a way that is in complicated manner. I try to explain it once again or twice just for you to understand. And I'm doing my best to what do you call this one? To at least rephrase what I'm trying to say so that you guys can understand what I'm trying to point out. All right. So that is all, guys. And I hope this really helps you. Thank you.